Hi, welcome to today's notes. Today's notes we're going to focus on writing equations for graphs and tables. And so I have quite a few examples for us to get started with. Let's go ahead and start with number one. Number one says find the slope of a line where we're going to remember that slope means rise over run, change in y over the change in x. Remember the shorthand you'll see me do is the change in y over the change in x. And also remember that slope means the average rate of change. So remember that slope is your average rate of change. So number two says to find the slope is to find the equation. Once you find the slope, then find the y-intercept of the line. Remember the y-intercept is the y-coordinate of the point where the line crosses the y-axis. It's also the value when x is 0. So if you want to think about it, the ordered pair will be 0, b, okay, so that y-intercept. And then the last thing is we're going to write the equation in slope-intercept form, which y equals mx plus b. Remember, m stands for slope, b stands for the y-intercept. Then the other thing that we're going to do with some of these is we're going to go ahead and convert them into standard form. So let's start with letter A. With letter A, I take a look at the values on my axes, and on my axes, they all increase by 1. So my rise is 1, my run is 1. Rise is 1, my run is 1. So m equals 1 over 1. My slope, my y-intercept where it intersects the y-axis is right here at 6. So the equation is y equals, we could write it as 1 over 1, 1, or just x plus 6. Okay, so remember that there's a 1 in front of it that comes from that slope. Now, to put it into standard form, a reminder that standard form, let's see, we'll write that right over here, ax plus by equals c. This is our standard form. We're going to start by subtracting x from both sides. So I have negative x plus y equals 6. And then I'm going to multiply the entire equation by negative 1 because remember that first term, that ax cannot be negative. So I get x minus y equals negative 6. I'm going to go ahead and write that on my line. Okay, let's go ahead and try B. B is the same idea. Again, take a look at your axes and notice that this time our intervals increase by 2. Okay, so I'm going to start with my finding slope. So you go from one intersection point to the next. So I'm going to start with this intersection point right here. My rise is 2, 4. My run is 2. So I went up 4, right 2. Okay, so I can also go in the opposite direction where I go down 4, left 2. Down and left are both negative, and so negative divided by negative, I have positive 4 over 2. So down and left are negative movements. Should have been clear about that. And then my y-intercept, my b, where it intersects the y-axis, is right there at 4. When I write my equation, I'm going to, again, write my equation in simplified form. So I'm not going to write 4 over 2. 4 over 2 simplifies to 2. So I have 2x plus 4. So there it is in intercept form. Now, same thing is I'm going to put this into standard form. So standard form, I'm going to start by subtracting 2x from both sides. So I get negative 2x plus y equals 4. Multiply the equation by negative 1, because again, that first term cannot be negative. 2x minus y equals negative 4. And we'll go ahead and write that on the line. Let's go to C. C is one I think we're going to just do next time I see you in class. Let's jump down to D. And I am going to apologize. D and E I know are hard to read. I tried to fix it ahead of time before these printed, but I did not fix it well enough. So I apologize. Just kind of do the best you can. So we're going to start with finding that average rate of change. We're going to look for where the points intersect, my intersection points. So I have a y-intercept. I have a point here. I have an intersection point there. So from one point to the next, we're going to count the rise. My intervals, I'll move by 1, so my rise is 1, 2. Then I go left. Left is a negative movement, so 1, 2, 3. So 2 over negative 3. I can try that again. So my rise is up 2, left 3. So up is a positive movement, left is a negative movement. I have y equals negative 2/3 x, and my y-intercept is at 4, positive 4 again. Then we're going to put this into standard form. To start putting this into standard form, I'm going to add 2/3 x to both sides. When I do that, we get 2/3 x plus y equals 4. And now I cannot have fractions in my ax or by term, so I'm going to multiply by my least common denominator, which is 3. So 3 times 2/3 x is 2x, 3 times y is plus 3y, and 3 times 4 is 12. So there it is in standard form. Okay, let's try E. So for E, same thing. We're going to find slope. Remember, try and look for those intersection points. So again, I apologize. We'll do the best we can. That looks like 1. This looks like 1. I know I got 1 all the way down there, and then maybe right there. Okay. So those seem to be your intersection points. So for this one, rise over run, so how much it goes up? It goes up 1, 2, 3, 4, right 1. Up 1, 2, 3, 4, right 1. So it was up 4, right 1. B, this time it's a negative y-intercept, no big deal. We'll just have minus negative 6. My equation, we're going to write it in simplified form. So instead of having 4 over 1, it'll just be 4x minus 6. Now, if you did write it as 4 over 1, I wouldn't take off. Okay. So again, into standard form. So I have negative 4x plus y equals negative 6. And then multiply everything by negative 1. So now I have positive 4x minus y is equal to positive 6. Okay? We'll do F next time I see you in class. So there was a lot going on with these 4. So if you do have questions or not sure what happened, make sure you pencil like a little star next to it, and then just, ask to review that in class next time I see you. All right, let's go ahead and flip it over. So over on the back, we're kind of doing the same thing where we're going to write an equation. Okay. Typically, when you write an equation, we will be writing it in y equals mx plus b form, in that slope-intercept form, unless they tell you otherwise. So we'll go ahead and practice that with these tables. So if we start with number 1, again, we have to start with our slope. Slope is the change of y over the change of x. It gets confusing because if you read a table is x over y, but we're writing the change of y over the change of x. So in a way, it flip-flops. So for x, they all increase by 1, right? So I can go ahead and put 1 down there. For my y, these all increase by 2. So there you go, that's my slope. The next thing I'm going to do is write b. Now this is the key thing. You have to remember, and we talked about this on the front, that b is your y-intercept. When x is 0, what is y? So if I look at my table, when x is 0, y is 0. So when I write it in slope-intercept form, I'm going to write y equals 2x. My y-intercept is 0. I could write plus 0, or I could leave it as is. Okay, so that's it for number 1. Now let's try number 2. So number 2, same thing. We're going to start by figuring out what slope is. Remember, it's a change of y over the change of x. My change of x, they increase by 1. My change of y, this one also increases by 1. My y-intercept. When x is 0, what is y? It's right here. 3.5. So in slope-intercept form, y equals, my slope is 1 over 1, so I can just write that as x. My y-intercept is 3.5. Okay, so that's number 2 for you. Let's go ahead and try number 3. Slope. Change of y over the change of x. X, again, increases by 1. Y, this time increases by 2. When x is 0, what is y? This time it's not given to us on the table. So you notice how our table has a pattern. X increases by 1, y increases by 2. Now to create 0, and I need to continue the pattern, notice all I have to do is subtract 1. Okay? That's to go backwards, but if I go forwards again, my pattern remains the same. 0, 1, 2, 3, 4, 5. Okay, increasing by 1. So, but again, to go backwards, we just reverse our pattern. So I subtract by 2. So my y-intercept is -1. So I have y equals 2x minus 1. Okay. We are going to do 4 and 5 next time I see you in class. These ones are a little bit more challenging because notice how your y-intercept is missing on both of these, okay? Number 5, it is quite far away. So I'll show you a different method to get there when it is very far away and it's not a simple backwards pattern. Let's go down to number 6, and so we'll go ahead and start number 6. Number 6, this one talks about Ryan works for a delivery service. The function f of n is used to calculate his daily pay in dollars on a day when he makes n deliveries. So here is our equation, f of n equals 7n plus 96. We're going to use the function to complete the table. Now remember that our tables are x and y, and so in function notation it's n and then f of n, okay? And we know that from if I would rewrite this equation, it would be y equals 7x plus 96. Okay, and so again, remember, our x comes first, and that's n in the equation. Y, again, for our tables, it's xy, and then we have f of n. So we have different parts to fill in. Let's go ahead and just do the first one. So the first one, they give us the x value. So it's f of n that we have to find. So what that would look like is I'm solving for f of n, so I'm going to leave that as is, and I'm going to put 0 in for n, and then I solve. So I have f of n equals 0 plus 96, and then f of n equals 96. Okay, and so again, to complete the table, I'll just go ahead and write 96 right in there. And to get us started with the next one, they give us, again, what n is. So it would be 7 times 5 plus 96. So remember, I keep going back and I'm using that equation. So I'm going to leave this one right here, and then we'll finish this one up next time I see you in class. All right, sounds great. Over and out.